Hi, my name is Wenbo. I'm currently a software engineer at Google working on external-facing, front-facing networking software, including GRPC, as well as HTTP and different web protocols. So in this talk, I'm going to go through the design choices we made for GRPC Web. So I started with a quick introduction of the GRPC Web and what's so unique about web platforms. And now I'll do a deep dive on the different design choices we made. The process of the design choices are really just about making the trade-offs, which you hope will be right over time as time proves. I'll end the talk with a brief discussion about the roadmap, which is really just showing you that this is really a continual process that we were constantly making different design trade-offs as we evolve the solution. So I'll try to leave 15 minutes for the Q&A, to discuss anything you'd like to ask about. So first I'll start to give you a quick introduction about gRPC. So in a nutshell, gRPC is really just an RPC framework, which allows the client to send a request to a server and then server send back a response. Currently, gRPC uses HTTP2 as the underlying transport protocol. The key to gRPC is really the service definition, which is using protocol buffer. So the service definition provides two things. One is a strict contract between the client and the server in terms of what are the input, what are the output, what are the methods. The second one is also give you a type system, which is code generated for the client and communicate to the server. So next slide, I'm going to talk about what's unique about the web platforms. If you want to extend, this kind of RPC model to web clients, and I'm going to skip the details which are specific to gRPC Web, and just started with HTTP. HTTP was actually designed as an RPC protocol, strictly speaking, as well. So the things that's really unique about web clients are two things. So first thing is, unlike the previous slide, as you can see, the client directly talks to the server. In the web case, as you can see on this diagram, the web clients, rarely talk to the server directly, except maybe in a local development environment. In most cases, the clients will talk to the proxies first. There's a forward proxies which provide some kind of firewall support. There could also be a reverse proxy that provide load balancer support or extra protection for untrusted, external traffic. And behind the proxies, there could also be gateways that will do protocol translation. In the case of gRPC Web, we actually rely on Envoy, the CNCF open source proxy, to translate gRPC Web to gRPC. So this translation is completely transparent to the RPC service. The second thing that's unique to web platform is, unlike server-to-server kind of languages, and the RPC implementation typically have the full access to the networking in terms of the TCP connections, the whole HTTP2 stacks. That's not really the case for web clients. Because of the nature of the security models, the sandbox-based security models, and the web, the JavaScript implementation for the RPC runtime have to rely on web APIs to access the underlying networking, which is typically much restricted and typically just a subset of features that are allowed to access from the browsers. And for example, you can't really control which HTTP version the clients want to talk to the server, right? It's all negotiated by the platforms on behalf of the web applications. There are also many other constraints here. So these are the really two unique things that's differentiated between the web-based clients and other clients. So next, I'm going to start to go through the whole, the whole set of design choices we made. Like I mentioned earlier, this is really just about making trade-offs, deciding how do you want to evolve and design the overall solution. Because of the constraints enforced by the web platform, and we learned that at the very beginning, we have to have a different protocol that is not a gRPC for product clients, for example, to talk to a gRPC server. So There are different choices. We can use different protocols, but we end up choose a protocol, design protocol that will maximize the compatibility between gRPC Web and the gRPC. Right. So, for example, the overall protocol will adopt any concepts or elements of the gRPC protocol concepts that can be implemented on browser. Even in some cases, it's not as optimal. For example, compression support. And we try to minimize the protocol changes to enable the gRPC on web platforms. And in some cases, we do start to introduce concepts that are very specific to gRPC Web, only because those concepts are very web specific, right? That doesn't really cause any overlapping with gRPC protocols, such as the call support, which is a very unique concept that only concerns the web clients. So the takeaway from here is that when you design a system like that, what we try to do is try to minimize the overall complexity of the system, not only on the client side, but also the whole client-server communication path. And at the same time, we want to be the solution to be future-proof. So the next design choice is, this very general kind of principle is just, keep everything simple when you could. Specifically in this case, we decided not to support all the streaming features, and we will only support server streaming, mostly due to the web platform constraints. And also the first design choice we made, that is try to maximize the compatibility with gRPC itself. And specifically, we will try to avoid using the protocol that requires a fallback. For example, if we had to use the WebSockets, then we still have to support the HTTP as a fallback, and then we end up a protocol which will be really, really complicated. And we choose not to support byte streaming or request streaming because, byte streaming or request streaming are unlike the traditional unary response request response communication or server streaming. They are much more error prone and also less scalable, especially over the internet. One key difference is, unlike unary request response or server streaming, in the byte case or request streaming case, the input data from the client may be lost during the failure, but there's no way for the client to know if the input data actually has been received or delivered on the server side, because you can't rely on the response or partial response to know that the request data actually has been delivered on the server side. This makes the whole failure recovery a lot more complicated. There are other concerns, but overall we think that is, we don't want to give you just an RPC solution, which by itself is not really going to solve all your problems. So overall, the key here is, try to not invent anything that we may regret that we have to support in future, right, for 5 or for 10 more years, right? So keep it simple. The next principle is, since we have already made all the trade-offs, sort of try to minimize overall complexity, then we decided, hey, we made all these sort of sacrifices, and we do think that we're at a better position at this point to make the solution work literally like everywhere. And we try very hard to make sure the gRPC web clients can work from any web platform. And this turns out to be really important. We don't have the story from external clients, but internally, we now have over 100 Google applications using gRPC Web, right? So we believe that, in this regard, we made the right choice. We limited complexity. At the same time, we are at a much better position to provide solutions that just can work from everywhere. So the next one is also, in my view, a very generic principle, is that you focus on what is actually true value add that you want to bring to the table for developers. In this particular case, we believe that the true value of the gRPC Web is to enable the developers to give them a seamless developer experience when or after they have already decided to use gRPC to build as a microservice server-side stacks. And gRPC Web will enable them to use the same kind of development model, the same kind of schema and the data model on both client side and server side. We think that this is really powerful. Again, if the developers have already decided to adopt the gRPC. The second thing is we want because of this benefit, we want to make sure that when you use gRPC Web, the kind of experience you're getting is not like a second-hand experience you would get, kind of like, you're using a solution that's forced on you by the choices the server-side stack developers make, right? We want you to feel like this is really first-class web development experience. As a result, we try very hard to make sure that the GRPC Web really fits into the web development experience. We want to focus on things like API, code generation, build, and also in terms of alignment with Node and support of the TypeScripts and all those things. And we believe that this is really important. Then try to optimize the so-called communication protocols. So overall, the summary here, I would think is, try to focus on the whole value adds, right? That you can really make a difference for developers. The next one is, I would say it's basically try to make REST a friend. I'm not going to get into the debate of what is REST, what is the RPC, why they're different, or are they really the same thing, all that. The thing really I want to point out here is that, GRPC Web is not really there to replace REST. There's a humongous kind of frameworks ecosystem that has been created over more than 10 years that really make the REST model very successful, and we want to leverage all those ecosystems. We're not there to reinvent things or replace what makes REST so easy to use or develop. But the key here is, as a principle, you need it. When you're making design choices, you want to make sure that you understand your target environments. In our case, we really want to make sure GRPC Web is something that's really easy for web developers to adopt, and that will in turn also make GRPC more widely adopted. So this, one second. So this concludes, all the design choices I'd like to highlight. To me, I really want to, highlight the purposes of, going through those design choices with you. Firstly, I want to give you a little bit more background about, how GRPC and GRPC Web works. If you are in the process of using GRPC Web, adopting GRPC Web, I hope this will help you understand better or more about GRPC Web, give you more background. The second thing is, I hope that these five design choices we made kind of represent a lot of the general design principles, which can also be applied, if you happen to be in the process of designing something, a new solution or a new system. That is basically minimize complexity, think about the future, and also try to be more developer friendly and thinking about the target deployment environment. So I'll conclude the talk to talk about it quickly about the roadmap. So obviously, we still want to give you better feature support and try to have feature parity with GRPC itself. And so we are very actively working with, for example, the web platform teams, the Chrome team developers, to try to evaluate how to support request streaming, which will also enable half-duplex spider stream. You can do a request streaming, basically upload, and then do a download after the upload is finished. That itself is not a bad thing. That's not the so-called full duplex spider stream. For the full duplex spider streaming, we don't really have an answer which we like or comfortable with that we would like to support for a long time to come. At this point, we just like to think about some kind of very easy workaround that not just give you a BiDi kind of support, but also it's easy to maintain and easy to scale. So we'll keep the GitHub updated with regards to those progresses we're making. At the same time, we're adding more support in the so-called gateways that so you can if you choose to support the GRPC Web but without using Envoy, you're able to do that. Today, there's already Swift and .NET support using this, Swift and .NET's native HTTP web frameworks. It seems to work really seamlessly. We like that, and we want to extend this support to more languages. Also, things like security features, we really want to rely on the language-specific web platforms to provide such support. And then last thing is protobuf improvement and performance. And I would summarize this as all those efforts are really basically a continuation of the same kind of design trade-offs we just discussed. And I think that's very important for us to stick with those principles. The GRPC Web has been developed by a very small team. In most cases, really just one or two developers. We, really appreciate all the help we're getting from the community, especially in the gateways, as well as the sort of ecosystem support. Try to run GRPC Web from different environments, different frameworks, and also report the success, report issues. We see a lot of contributions or activities on GitHub. So thanks for the contributions. And lastly, we really want to hear your deployment experience. If you have been using GRPC Web and GRPC very successfully, you build your entire web applications using GRPC Web, drop us a note. You can send me an email directly. Here's my email address, and we'd like to hear from you. I think this concludes my talk. Thanks so much. Look forward to the live discussion with you. Thanks.
Hi, hello everyone. Yeah, I think I'm on the air right now. I'm going to take questions, and I'm going to publish each question I got on the platform, and I'll read the first question I'm getting. So Vakantash is asking, is it like use gRPC for inter-service communication in microservice world? I would, if I understand the question correctly, gRPC Web fundamentally allows you to adopt the same kind of microservice deployment or development model, similar to server-side kind of microservice deployment, right? So you can imagine that when you're doing the microservice, you have different applications talking to each other, usually from VM to VM. Now with gRPC Web, you can have your mobile clients also talking to those applications kind of in the same kind of microservice world. Now, of course, because the clients are running on internet, there are different security constraints of things. But fundamentally, I would think of this I would look at this as an extension of the microservice world as opposed to inter-service communication. Now, inter-service communication, if I understand this correctly, you're probably talking about like APIs, public APIs. Those are provided by API gateways that could still support a use of gRPC Web or gRPC as a transport, but there are those public API specific features, things like there's more, control plane functions, things like billing, different those things, authorization. Feel free to add, if I didn't answer this question clearly, feel free to submit a follow-up question. Otherwise, I'll go to the next one. So John is asking, is gRPC Web faster than REST APIs? gRPC, so the question is, at the networking layer, the latency of using gRPC Web is really decided by the broader APIs, right? All the networking APIs provided by broader and also the server-side stack. So gRPC Web will be faster than REST API, not because of the networking stack, but because of the protobuf. Because protobuf is more compact, and it was basically it will save bandwidth. If the link is not the bandwidth of the link is not very high, potentially the gRPC Web can be faster. However, the caveat here is the protobuf, the current protobuf library we published, we open source, only support the so-called binary encoding format. Within Google, we're using a more like a JSON encoded protobuf format, but it's not exactly JSON. It's not the protobuf translated JSON messages, but the encoding it's more like it's text encoding. So that format is far more efficient than a binary format as it's being currently implemented. So to answer your question today, probably not. Right. So if you're using gRPC Web, the main benefit is not the performance. The main benefit is that you can talk to a gRPC endpoint more seamlessly. The next one is also from Venkatesh asking about upload support. file upload support. Now, potentially, because there's the existence of a proxy or gateway between the browser and the gRPC server endpoint, potentially, yeah, we can support something like that. But as what I talked about on the slide, you don't want to limit the scope of the gRPC Web instead of trying to do all kinds of things the web allows you to do. So I think this is a good feature for some ecosystem to provide. For example, there is a popular what I believe called JRPC gateway, right? So this gateway does support all kinds of different things. I think that would be a very useful feature for the gateway to support. But JRPC Web, the value of the JRPC Web is provided the client-side developer experience, the same kind of code gen, the same API as Node, and all that. For that, I don't feel like this is a feature JRPC Web should support. So the next one is Nagnath is asking how compatible is JRPC Web with Java EE server backends? Yes, I used to work on the Java server specs, all that. So I think the intent. So we don't have. So. And which is part of the EE server stack. We publish a Java gateway. The intent is that it will be compatible with all the web stack Java EE provides. By Java EE here, I'm just referring to the server spec, not everything else. That's probably not related to JRPC Web. But if you have other questions related to EE, I'm happy to answer. Just drop a follow-up question there. So I'm going to publish the next one. So Eagle is asking, so is JRPC Web considered stable and robust enough to use in place of a classic HTTP REST? The answer is yes. And internally, we're also in web of all the things have been deployed in production, but the number of projects that actually actively using JRPC Web is over 100, right? So that's part of the reason we are very cautious about what to support, what not to support, because we want Google the own, the web apps is also using JRPC Web. So yeah, it's definitely stable and robust for production use. And you mentioned that I tried to since this is a one-way discussion. If you are thinking about things like HTTP REST is going to have no compatibility problems. If you're talking about on server side, on the proxy side of things, yeah, JRPC Web is definitely compatible with HTTP. And for the purpose of HTTP REST, you shouldn't, if you can do HTTP REST, for environment, and then you should be able to do JRPC Web as well. I would say, the real difference is really the content type is different. Otherwise, it's practically, I wouldn't say REST, but it's just like REST as far as the general web environment frameworks are concerned.
Okay, I guess the audio is working. Sorry, yeah, we have some problems with the audio. And the next question is, what is the recommended tech stack with JRPC Web? I'm not too clear what exactly you're referring to as tech stack, but generally JRPC Web on the client side is just a JavaScript libraries. You should be able to use it from any web frameworks. On the server side, the JRPC endpoint, the JRPC server itself, shouldn't know about any difference about this is coming from a JRPC web client. The web the gateway is the proxy. So today we support Envoy as the official proxy, and we are developing the different in-process language-specific proxies as well. For all those proxies, we'll be using the standard web frameworks to terminate the JRPC Web requests. What that means is we'll be using .NET, Swift, and Java Servlet, all the standard web frameworks to terminate the requests on the server side, which means that they should be able to integrate. If you have like your own auth wrappers, cross-origin wrap, security filters, those things, those modules should be able to work on top of the JRPC Web. That's our design goal. So I'll try to go back to some of the questions I already answered since the audio has some issues. So one of the questions about the EE support, the Java EE support, and we're going to publish a support on server side to have the servlet framework, the standard Java servlet framework, to terminate the JRPC Web and then talk to the JRPC server, to the Java servers. And then you can use Apache, you can use JID, those frameworks. Then there was one question about the file upload support. My answer is that this is the future, maybe more suited for the GRPC Gateway, which is another, it's a community contributed project. And for GRPC Web, we like to sort of be aligned with all these sort of microservice languages like Node, which will not support file, something like file upload. And this was a question about is JRPC Web faster than REST APIs? The answer is not really. The latency of performance is mostly decided by the protobuf messages versus JSON. We will publish a better protobuf JavaScript libraries, which will be able to encode the protobuf messages in a more efficient format. And Google is using this format for many, many years, but it just takes a little bit of time for us to open source this library. Let me go through other questions. So there's a question about the Spring. If Spring is using servlets, then it will work once we have a Java proxy published. But otherwise, I don't think we're going to have anything specific to Spring, the Spring plus JRPC Web integration. There's a question about where can I find the latest documents and reference examples for Java. So everything will be published on the JRPC Web GitHub repo. We will make some kind of announcement or publish a blog about this once everything is finished. We're still developing this the Java support. I think I have maybe 1 minute. There was a question about is JRPC Web stable or robust enough? The answer is yes. Google internally we've been using JRPC Web for a lot of applications. We have 100 applications is using JRPC Web in some form. Oh, I believe I have actually 5 more minutes. Yes. So the next question is, where do you see JRPC Web in the next 5 years? I think here's my sort of opinionated views about this. It's a good question. I think that depends on a few things. First is how JRPC will be evolving. The way I see it is JRPC has a lot of adoption, many language support. So the bar to introduce protocol change or anything like that is very high. To assume that's the case for JRPC, that JRPC itself is very stable, with more and more focus on the microservice kind of deployment, then it's really up to JRPC Web to match the JRPC. I'm talking about the web protocol that. So that really depends on the web platform, how web platform is going to head into. So for example, I am working on this thing called Clone Origin trial to decide how do we support the current streaming using fetch streams. The things that we cannot decide is we limited the fetch streams to, for example, only HTTP 1.1 because the general web community believe that because web browser doesn't support certain features in HTTP, chances are there are a lot of servers, proxies, firewalls will be broken if Web suddenly starts to support a new thing. So my experience with web performance is slow in adopting anything new, and also anything comes with security risks. So I don't know if in 5 years we will GRPC Web or web clients will necessarily have a way to talk to gRPC directly using the exact gRPC HTTP2 protocol, but it's certainly a possibility. And then we were working with the broader vendors on that as well. On the flip side, web is also evolving. There are certain technologies will be available on web first. But the best example is like HTTP3, HTTP2, HTTP Quick, all those things actually become available on the web on browsers first. So I think there's an opportunity for gRPC Web to adopt those like a really groundbreaking kind of communication stacks. And we are actually, when you're using gRPC Web from Chrome, for example, you are talking to, let's say, Google.com, you are always, by default, you're always using Quick, right? It's just the web API has a limitation, but the web platform does support, and more advanced communication stacks, and that stack will evolve very rapidly as well over the next 5 years. So Venkatesh has another question about the Java framework. Basically, the question is, will all the Java frameworks support gRPC once gRPC Java proxy is available? So my understanding is pretty much all the Java frameworks on server side, right, is supporting serverless specs, includes Spring, EU things. So yeah, I hope so. I hope that's the case. But I don't have a good sense of how many all the Java frameworks are supporting serverless today. The next question is tool to test and debug gRPC. Yeah, we do see people start to develop either like Chrome extensions to debug gRPC Web, those things. So I think we will try to publish those tools or those contributions over time. And also gRPC Web, when we start to work on gRPC Web, our belief is that people using gRPC, people tend to use web or browsers as a way to debug gRPC itself, because when mobile probably is more popular than web in some cases, but for debugging, for troubleshooting, if you want to have something actually can see it, you can easily interact, with a server endpoint. Yeah, typically you want to use web. So we do have thoughts about making, for example, have built some kind of forms that you can directly input protobuf messages on browser, and to invoke a gRPC endpoint. I believe those kind of features will be very useful for debugging gRPC, not just gRPC Web. But those, it's a lot of work. And if you have anything you want to contribute, let us know. But it's something we on our roadmap. The next question is, any example of where gRPC Web is used in Google to relate? So in Google, the way things are going is very much sort of match what we want people to use gRPC. So basically, the web development becomes more and more API driven. I would still categorize those APIs as internal APIs, or what you call the first question refers to as a microservice APIs. Not exactly, but basically it's the same party access, right? So it's like a Gmail application talking to a Gmail server, that kind of use case. And the gRPC is the standard API, RPC to the APIs for Google's APIs, like internal APIs for applications, mobile applications or web applications. So yeah, I think over time, most of the Google, especially the new web applications, will be using gRPC and the gRPC Web. basically they will all be using gRPC on the server side. Then obviously you want to use gRPC Web on the client side. Then you basically, the client and server speak the same kind of RPC in terms of metadata, protobuf, all that. There was another. So John's asking again about gRPC Web is faster than REST APIs. I'll just repeat what I said earlier. I believe currently I don't think there's any latency difference if you're using gRPC or gRPC REST. I think the difference will be decided not by gRPC Web clients itself. It will be decided by the whole entire server-side stack. Obviously, if you're using REST versus gRPC, the server-side stack is very different. We are working on open sourcing a new protobuf for JavaScript like a library, which will support a more efficient encoding format. Yeah, so today Google is using a different format than the binary format from the browser clients. This will really improve the gRPC Web performance and also make it more secure to do gRPC from the browsers, because generally sending binary data, involves some security risks compared to text format data. So yeah, so this is definitely our roadmap to publish a more efficient protobuf library for web applications. And when that happens, I do believe that the gRPC Web will, not necessarily, will be faster than if you do JSON REST, mostly because the messages will be a lot more compact, smaller basically in size compared to JSON. So any estimate on the new library? Mario was asking, I suppose we're talking about the protobuf library. Unfortunately, no. And the problem is this format, so internally we have multiple formats, so we kind of have to unify the format before we publish it. The problem is once we publish the client, we have to support the format, and also we have to figure out what to do on the server side because the transcoding is involved. It's a different format. Another reason we are not in a rush to publish this is we're also actively trying to improve the binary performance. In the case that the binary performance can actually beat or match the text encoding format, we may or may not want to publish the text format, text encoding format, because it's a different protobuf format that's only used by browser clients. Yeah, unfortunately, that's the best answer I have at this point. Okay, so I think I covered all the questions. And I will, if you have any follow-up questions, and please, go to the Slack channel. I will be there for the next 30 minutes to answer any questions you may have, or you want to talk anything without publishing the questions. That will work too. Thanks, everyone.